In this video, I'll demonstrate the use of InnerJoins or EquiJoins on our bookstore database. Before we get started, let's take a look at the EER diagram for this bookstore. So basically, we have a customers table and a customer can place orders. And then when they place an order, we want to know what they bought. So we go to the order item table, which has an ISBN in it. And then from the order item table, I can see what books that they have purchased, not based on ISBN, but I want to look at the title, maybe the publication date, the cost, the retail, the category of the book. We're in the computer category, family life. These books are published by publishers, so I can get the publisher name over here. And then obviously they're written by an author. Now what we have here is what we call a junction table, because an author can have written many books, and a book can have more than one author, and this table basically keeps track of the ISBN and the author ID. So in this table, an ISBN may show up twice because it's been written by two different authors. And then of course the author ID can show up more than once because they've written more than one ISBN. So as we work through our joins and ask questions about the data in this database, you're going to have to become a little bit familiar with what kinds of information are in each table. So you may want to take a printed copy of this and have it available. So let's do an example. Let's say we want to see a list of customers, their orders, and the order date. All right, well, obviously the customers are going to be in the customers table, and I just said, well, let's just grab their first and last name. All right, their order number is in the orders table, and the order date is in the orders table. So again, looking over here, I can see customer number, first and last name, order number, order date, there's a ship date, ship city, ship state, so this is the orders table. So now I am going to say, what tables do I need to get this information? Well, I'm going to need two tables. I need the customers table. I need to join that table to the orders table. And then I have to specify the connection between those two tables, the related column. So in this case, it's customers.customernum equal orders.customernum. Though that is the common column between those two tables, and you can see it over here. Customer num is here, and the red diamond is customer number over here. As long as we're on this page, what's the common column between orders and order items? I have a yellow key, order num. Over here, it's a red key, but nonetheless red, showing me that that is the common column, order num. Okay, how about order items to bookstores? What's common? ISBN. So here's the key, ISBN, and in this table, it's a red diamond telling me that that's the foreign key. So typically red means foreign key, yellow means the primary key, and in this case it happens to be both the foreign and part of a composite primary key. So anyway, here we are, there's my connection. I have to specify it, and just for fun I'm going to order by last name. So now when I run that, here are the results. I can get the last name, first name, I ordered by that. The order number, so Kenneth has placed two different orders, and then there's the date that he placed those orders. Now let me show you a way to kind of speed up that typing. It's kind of a pain to have to type customers.customernum, orders.customernum. And so there's a way that we can abbreviate that, and it's called table aliases, very similar to column aliases. So as I type that same command, last name, first name, order num, order date, I'm going to say from customers, and I'm going to alias that table, and I'm just giving it a one-letter name because I don't want to type a lot. So I'm going to say as C. So from here on out, when I refer to the customers table, I'm going to refer to it with a C. And I'm going to join orders as, and I'm just giving it a one-letter alias, O. And I'm just making this up, but of course you want to do something that makes sense. So the letter C stands for customers, the letter O stands for orders. A one-letter alias. So now when I say on, I can say C dot customer num equal O dot customer num. I don't have to spell out the entire table every time I type it. And so again, order by last name. So that command is exactly the same as this one. I'm just trying to eliminate some typing right there. Now another reason to use aliases like the C and the O is because very often you have to specify what table your column is coming from. Now right now I didn't. This will run just fine, and only because last name is only in the customers table. There's no ambiguity about that. It's only in one table. Same with first name. Order num is only in the order table, and order date is only in the order table, right? So hey, it says I understand where these columns are, I can find them. But what if, as part of my select statement, I want to also display the customer num? All right. Well, guess what? The customer num is in two tables. It's in the customer table, and because it's the common column, it's in the orders table. So when I go to run that command, and I'm going to get an error, and the error is unknown column customer num. Oops, that's not the error I wanted. Put in that comma. Now I'll get an error. Customer num in field list is ambiguous. So you'll get that word ambiguous. It says, hey, I don't know what you mean because there's two columns called customer num. So at this point, you have to specify c.customer num tells me it's from the customers table, or I could do o.customer num, meaning it's from the orders table. Now, of course, the result's the same because the whole idea is I'm joining on that column and the numbers are the same in each column. Okay, so very often, just out of habit, you'll get to put in the table aliases in front of all your columns, so you just don't have to worry about it. So I'll go c.last name, c.first name. The order is in the order num is in the order table, and o.order date. So when you look at SQL on the internet or start typing your own, very often you'll alias your tables. You'll use that alias in front of each column, and then that will eliminate that ambiguity error. And now I get my results back with the customer num showing, and then of course the things that the order number and the order date. Another trick to eliminate a little bit of typing is there's a keyword called using, but it only works and when the conditions are just right, and it only works on some systems. I know it's not available with SQL Server, but it does work in MySQL. So here's how it works. When I say from customers as C, there's my alias, join orders as O, instead of telling it this customer or this column equals that column, I can say using and just list the common column. Well, the reason this works is because that column has the exact same name in both tables, right? If these columns were different names, I couldn't say using. I would have to use the on keyword and say, oh, this column equals that column and actually spell it out. But because they have the exact same name, I'm able to get away with this using keyword. Just saying using that column, the system's smart enough to recognize that name as the same in both tables, and so then it'll run just fine. So now if I run that, it works. I get the same data. And it's a little less typing. The beauty of this bookstore database is order num has the exact same spelling, so I can do using on that. ISBN, exact same spelling, right? Author ID. So very often in this books table, I can get away with that using keyword because the columns have the exact same name. But in other databases, that's definitely not the case. In which case you have to say this column equals that column because they may be spelled differently. Now, just to twist this up a little bit, what if I wanted to know the same thing, basically the customers who have placed orders and they live in Florida, they're from Florida. Okay, so the only thing that's changed in this case is a where clause. I still want their last name. This time I threw in the address column from the customer table, the state column from the customer table, order num, order date. I use the on keyword. I could have done using, right? In fact, right here I show you that either one of these from clauses will work. This one's commented out, but I could say using customer num. And then I'm saying where the ship state equals Florida. Now the ship state is in the orders table. That's why I have an O there. O stands for orders. When I run that, I get all the orders from people who live in Florida, or at least their ship state's in Florida. Okay, it looks like it's coincidental that the state they live in, because that's where this CE state, customer state, is the same as the ship state in the order table. Now let's take a look at this next question. I want to find the customers, their orders, order date. Ooh, the book that they ordered, how many did they order, and how much did they pay? So when you see that question, your first thing is, oh, well, what table contains the books that they ordered, the quantity, and paid each? So you run over here and go, okay, well, the orders, I just have the date and where it was shipped. It's going to be order items. That tells me what book they ordered, the quantity, and how much they paid for each of those items. So I have to join 3 tables because customer information is over here. Order item information, the quantity, ISBN, paid each is over here. And then, of course, the number and the date are here. So I have to connect those 3 using their common columns. So here's what that looks like. Scoot this down. I'm going to select, in this case, last name, order number, order date, ISBN, quantity, and paid each. Those are the columns I want to see. Well, that's in 3 different tables, which means then that I have 2 joins. So right here, I'm going to go customers, join orders, using customer num, and I'm aliasing those. So that's an O and a C. Join order items. So you just continue on saying join order items, and my alias in this case is a 2-character one, OI, right? You just want to do something short that makes sense. So this for me stands for order item, using order num. Now I also threw in this little thing about I only wanted to see those things where the order date is after this particular date. So now I threw in my where clause. I'm going to scoot that back out. So select from where order date is greater than, and remember in MySQL when you type a date it has to be in quotes and then the year, month, day format. So that will find the customer name, order num, date, and then what did they order when I run that. So there's their name, order num, date, and now I can see what they ordered, and this information is coming from the order items table. Now, oh boy, let's stretch this a little bit further. I want to see the list of customers, again, their orders, order date, ISBN, quantity, paid each, same as before. But ISBN is not doing me any good. I actually want to see the title of the book and the category that it comes from, the category being computers or family, life, business. Ooh, so that means where is that information? Well, ISBN is in the order item table, but that's connected to the books through that common field. And here is the title, and here is the category. It's in this table. So because I want the customer name, and I want the title of the book that they've ordered, oh boy, now I got to connect to that table, to this table, to this table. So that's 4 tables, which means I'm going to have 3 joins. So running over here, I've selected my columns that I want to display, right? And I added B title, B category. I'm doing customers join orders using customer num just like before. Now I'm joining order items using order num just like before. But here's my 3rd join. I now have to join all of that to books using ISBN. So the common table or common column between the order item table and the book table is ISBN. All right, so I'm saying only show me books where this ISBN in the books table matches an ISBN in the order item table, and only show me orders where the order number in the orders table matches the order num in the order item table, and then of course where the customer number matches the customer table to the order table. So and I still have my where clause at the very end. So now when I run that, I get this same results, except I've added additional information. Here is the title of the book, and there is the category that it came from. So that's all of the books that were purchased after April 1st, 2009, and the customers who made that purchase, the order num and the order date. So let's do 2 more examples and then we'll quit on this video. So the next one is show me the authors who wrote the books in the family life. I should probably put category. All right, who wrote the books in that category? So looking at your EER diagram, where's your authors? They're over here. Okay, it's connected to this table through the author ID, common column. ISBN is the connection there. Okay, I want to know the last name, first name of the authors who wrote the books where the category equals family life. So that means I need to join these 3 tables, which tells me that there's going to be 2 joins. Let's look at our example. I got the book title, book ISBN, and I wrote the author last name. If I wanted, I could go ahead and throw in the author.fname, which is first name. So here we go. From books, you don't have to have the as keyword, so you can just say books space B, and the B becomes an alias. A lot of times I do throw in the as keyword because it confuses students when they see books B. They don't recognize that B as being just an alias, another name for that table. And so then book author, well, I used B for book, so I have to come up with another alias. So I say BA for book author. And this time, for just to be different, I use the on keyword. So I'm saying B.ISBN equal BA.ISBN. I could have used using ISBN because it has a common column name. Now, remember there's 3 tables, so I have to have 2 joins. So now I'm going to join to author, and I'll go ahead and put in my as keyword. As A, so that's my alias, on author ID equal BA author ID. And then, of course, here's my where clause, where B.category equal family life, because that's the authors I wanted to see were the people who wrote books for that category. So I run this example. And here we got, I have the title of the book, the ISBN, the author's last name, and the author's first name. And if I wanted to, I guess I could throw the category in. So I'll just go comma B.category. Just to confirm my where clause is only pulling back books that are from family life. So as I move that up, yep, everything's family life. So the last example, and the most annoying one, is I want to know which customers bought books from author James Austin. Okay, let's go look at our EER diagram. Bummer. Which customers bought books from this author? Oh my goodness. So I'm going to need to connect from customers to orders to find the customers that placed orders, right? Common column. Connect to order items. And then possibly, and we're going to talk about this, connect from order items to books, books to book author to author. 1, 2, 3, 4, 5, 6 tables means 5 joins. Now, there's a shortcut here. Notice the bookstore or order item table has an ISBN column. The book author table has ISBN, right? Because that tells me which author wrote which book. So as long as in my query I don't need the title or the category or any of these other pieces of information out of this table, I can connect ISBN to ISBN between these 2 tables. So in other words, I can join customers to orders, orders to order items to book author because they have a common column. Now this is a situation where the primary key of one table is the foreign key of another. Well, that's not really the case, but the column is still common. It's hard to say. So I can get away with this. An ISBN is an ISBN, and I only want to pull back records where there's a match. And then finally from here I can go to author ID. So as long as the question doesn't ask for the title of the book, then I'm good. I just wanted customers who bought books from James Austin, I think it was. So I can go around this way, make a connection between these 2 tables, and then get to book author. So what that looks like, let's just start with our from clause. Customers to orders using customer num. Got it. Join order items using order num. Yep. join book author. So here's where I'm making that jump. I went from order items to book author using ISBN. Right? So basically I went from order items way down here to book author. And then I'm going to join that to author using author ID. Don't know why I made that a capital A. Okay, so those are my aliases. Now, which columns do I want? Last name, maybe the state they're from, the ISBN of the book. Oops, did I use? Oh, that should be BA, the book author table. The author last name and the author first name. Okay, notice I'm doing something a little tricky here. I said I want it from Austin James. Well, there's two separate columns. So I'm going to concatenate the last name and the first name with a space, because that's a WS, and set that equal to Austin space James. Now, of course, what I could have done, not to be so tricky, is just said where L name equal in a single quote Austin and F name equal in a single quote James. So both of these where clauses accomplish the same thing, but this was just a little, I don't know if it was less typing or not, but kind of a chance to use a string function here. So let's select this and see if it runs. And it does. So now I'm getting the last name of customers and the state they're from, the ISBN, and of course the author's last name, and it's always the same because that was the whole point. Show me the customers who have bought books from James Austin. All right, so I think that's enough examples to hopefully get you going using an inner join. Real quick, why was this called an inner equijoin? Well, basically an inner join is one where we're bringing back records that are common or have a connection in both tables. Next week we're going to talk about outer joins, where I want to bring back records that have a connection, but also records that don't have a connection in both tables. Looking at a graphical example, first of all, there's several kinds of joins, inner, left, right, outer. Right now, we've just been playing that with this one, where we have a customers table and an orders table, and I want to see only the customers who've placed an order. All right, because later we could talk about an outer join, in which case I could say, show me the customers who've placed an order, but also the customers who've not placed an order. So that would be a combination, all my customers basically. So right now we're just doing inner join, and the reason it's called an equijoin, getting rid of this, is we're doing a join where we're saying this column equals that column. Because there is also a join where we can say join this column on that column when the numbers are between or greater than, or it doesn't have to be an equality necessarily. But again, we'll do that next week. So just today, all these examples were inner joins, and they were called an equality join or an equijoin.